This is the final screencast for A2 acids and bases. It is choosing indicators for acid-base titrations that are based on the pH curves that you learnt in the previous lesson. So the things you actually need to do for this part of the course, this tiny little bit we've got left, is to recall the pH ranges of common indicators. So the two that you need to know are phenolphthalein and methyl orange. So those are the ones where you'll have to remember them. And then you need to apply your knowledge of pH curves to unfamiliar indicators. When you're given data for them. And there's an example of that on the very last slide to show you how that looks in a question. First, we need to define what indicators actually are. The chemical structure that I've drawn for you here is phenolphthalein, which is an indicator you've used lots of times before. And you might remember that it is pink when it is in base, and it is colourless when it's in acid. So you can see here that the chemical structure of phenolphthalein changes depending on whether it's in base or in acid. So it's got a protonated form here on the right, where it's got this ring in the middle, and you'll notice that you've got an OH here rather than a double bond O. And on the left you've got the ring opening and you've got a negative charge, so that's the deprotonated form. It's important here to remember that these are pure chemical indicators that we're going to be talking about at A level. Probably what you remember as being indicators for when you were lower down the school will be things like a universal indicator, but that's actually a mixture of indicators. So in this case, we have indicators where there are two forms of the same substance, and those forms have got different colours, and that's what makes it an indicator. Thing to remember as well is that indicators are themselves weak acids, and therefore if you're going to add them to a titration, this is why we add them in a minimum amount of only a couple of drops, because they could potentially have an effect on the end point of your titration if you put too much in. So I said earlier on there were two indicators that you needed to learn, so you needed to be able to remember these, and there were other indicators you had to apply. So let's have a look at the indicators that you need to learn. So they are phenolphthalein and methyl orange. Now, you don't need to know anything like their chemical structures or any of those things that I put on the previous slides. All you need to know is the pH range that they work in, so that you can then make a decision about their usefulness for different combinations of acids and bases. So here on my diagram, I have put in the long straight bits that we looked for on those previous ones. I haven't put the other bit of the curve coming out from zero. I've just put the important bit at the equivalence point, so we can see where this matches up with our indicators. So let's look at phenolphthalein first, because I think that's the one that's the most familiar to you. So I'll just draw on here for phenolphthalein. So phenolphthalein actually will change colour in the range of 8.3 to 10. So let's see if I can find that on here. So from about there, 8, 9, 10, to about here. Okay, so you can see this on the graph. And it is pink in base and colourless in acid. So you can see that you would get that pink colour coming through here, just as you switch it over. So what you can see there is that phenolphthalein is suitable as an indicator for the strong acid, strong base curve and for the weak acid, strong base. But we can't use phenolphthalein if we have a combination of strong acid and weak base, because we wouldn't get a colour change within that long straight portion of the pH curve there, so it's not even touching it. So it probably won't come as a surprise that methyl orange is the opposite. So that changes from about 3.1 to about 4.4, 4.5-ish. So we'll just draw this on here. So you should be able to see, I'll just draw it in the right colours for it as well. So it is more red the more acidic it is. So kind of down here it's a reddy colour. And then it becomes more yellow here, and I think you'll remember that it goes a kind of orangey, salmony, pinky type colour at the end point for you. So that's methyl orange, and you can see that we can use methyl orange because it crosses over on the equivalence point for the strong acid weak base and also for the strong acid strong base. So you can see from this that the strong acid strong base is the easy one. You can use either of these indicators for it. The only difference is when you change one of the components to a weak one. So that's what you need to just learn and summarise for yourself so that you can answer questions that just rely on your recall in the exam. Beyond you just having to know the phenolphthalein and the methyl orange, you can be asked questions about indicators that ask you to apply your understanding of these pH curves and the long straight bits of them, the equivalence points, and some kinds of indicators that you haven't met before. And then you just need to be able to pick the right indicator from that or suggest the suitable indicator. So this question's from AQA from 2010. It actually was a question that had ethanoic acid and sodium hydroxide, so I'll just write that on the top. So that means that we are working with this weak acid, strong base curve here. I've just put the same diagram on as I put on before for convenience. So let's have a look at the indicators that we've got. So I'll label them A, B, C and D. It's not particularly complicated, this. So if it was thymol blue, it says that the indicator pH range where it changes is 1.2 to 2.8. So kind of there to kind of there. So that is indicator A. So we know that that's no good because it's not touching our pH curve at all. So let's do the next one, bromothymol blue, which is from 3 to about 4.6. And again, it's not touching our curve at all, is it? Next one, litmus, indicator C, from 5 to about 8. So that looks pretty good. But it's not all of it, is it? So it's touching it, but the whole of the indicator range doesn't match up with the whole of the pH range for this bit here. And it also, crucially, doesn't include this middle portion of the long straight bit. Okay, so that where the average kind of middle is. So ideally you need to cross over with that. So that was litmus indicator C. So let's look at Cresol purple, which was 7.6. So that's, I'll just pick up a different colour so it's easier to see. That's going from about here to about 9.289. So it's going from here to here. So in this case, the Cresol purple, the D, is the best one because the whole of the indicator range is overlapping with the equivalence point of the curve, so it's all being contained within it, and it also does overlap with that number, which is the average end point. So the whole of the range is in there, the whole indicator range is in the straight portion of the pH curve, and it overlaps with the midpoint of that end point. So the answer to this one is Cresol purple. So what I want you to do now is to have a go at this question. On the left there are 4 pH curves, A through to D. You'll recognise these because they turn up in lots of AQA questions, because the exam board doesn't want to get someone to draw them some more of them. And on the right there, you can see there is a table of acid-base indicators, and there are 2 questions. All I want you to do is to put the answers to those in Showbie for me.